Hey guys, welcome back to the video where today we'll be talking about chemical bonds, more specifically covalent versus ionic bonds. If you guys have not checked out the other videos, go ahead and check that out. We're just making this real short and quick for you guys to really understand this, okay? So what do I have here? I have covalent bonds. So what are covalent bonds? So covalent bonds are when atoms share a pair of their valence electrons, right? And what is an example of this? Well, first, before we even jump into that, I want to revisit this term right here, molecule. What is a molecule? A molecule is something that's held together by covalent bonds, right? So in order to make these molecules that we talk about, it's important that we understand that covalent bonds are used to form these molecules, right? Because we loosely use molecules, compounds, atoms, blah, 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 all together, right? But now we know that covalent bonds are responsible for molecules to be formed, right? So an example of this would be hydrogen, which is the very first example that I have right here, right? So again, how are they formed? So we know that hydrogen, if we look at our periodic table and blow this up, let me be careful about saying blowing up, right? Hydrogen does have one electron and one proton, right? So we know it has one electron, as seen here in this first hydrogen, and in this second hydrogen, we see that, I'm sorry, oh man, my phone. We see that they can form a covalent bond, right? So this one hydrogen has one electron, and this second has another electron, right? Now, these can be covalently bonded by sharing their electrons together, because we know that for hydrogen, if we blow up something here again, in this very first shell of hydrogen, it can only hold up to 2 electrons, right? It can only hold 2 electrons. So to fill this first shell, what it would do is it would grab another hydrogen, right? That also has one electron. Oops, let me erase this. And they would go ahead and share these together, making a covalent bond, right? So if we go over to our first slide, in this second step, we can see that these 2 electrons form a bond together here, where these 2 hydrogens now share those electrons to satisfy filling up their shell, right? Now, if we look at an example like oxygen, this is something a bit different, but the same type of concept, right? If I scroll over to my right, we see this statement here that says that this is all to satisfy the octet rule, right? Now, what is the octet rule? This is a rule where these atoms want their outer valence electron shell to hold 8 electrons, right? So if we look at oxygen, we have 2, 4, 6. We have 6 electrons, right? These 6 electrons are more specifically, as far as their location, are in the valence shell, which is the outer shell of the atom, right? Now, it wants to try to reach this octet rule where it has 8 electrons on its valence shell. So how does oxygen do this? So what will happen is, if we look at this other oxygen atom, so we have the first one here and the second one there, right? So what they would do is actually they would share their electrons, right? And that can be seen right here. So again, these oxygens have 2, 4, and 6 electrons. So what they would do is, again, they would share their electrons to make that 8. So this first one has 2, 4, 6, and now 8. And so does this other one to our right. It has 2, 4, 6, and 8. That is all to satisfy this octet rule. So now, another thing I kind of want to get into before we get into the next bond, which would be ionic bonds, is an understanding of electronegativity. So as we move all the way up through the periodic table, the more right and up an element is, the more electronegative it is, right? So if we go on to our third slide, now ionic bonds, I like to think of it as electron stealing, right? So with covalent bonds, they share. These atoms share these electrons, they're more friendly. However, we have these ionic bonds which steal from one atom to the next. Again, we can see the electronegativity here. And again, the more right you go, the more up you go, the higher the electronegativity would be. So if we even blow this up even more, we know that chlorine will be more electronegative than sulfur. And we know that fluorine would be more electronegative than chlorine, right? So why is this important? This is important because this determines which atom will kind of take those electrons. The atom that is more electronegative will take electrons from that atom. And we have an example right here, which is sodium chloride, which is sodium and the chlorine atom, where chlorine has more electrons. It has 17 electrons in total, and then Na, or sodium, has 10 electrons. And if we go back to our little periodic table, we see chlorine, and then what was the other one? Na, which is right here. And if we go based off of our chart here, we can see that chlorine is way further to the right than sodium is, right? So this means that chlorine would be more electronegative, and chlorine is going to be the thief. It's going to take this electron from sodium, and they're going to form something called an ionic bond, as to where they're not sharing electrons. This time chlorine is taking that electron from sodium. And how is this favorable? Well, if we look at chlorine, its outer shell has 2, 4, 6, and 8. Octet rule is satisfied. Now for sodium, we have 2, 4, 6, 8. And for its outer shell, octet rule is satisfied. So both of them are real happy because they satisfied that octet rule. So I'm going to end the video there, guys. Just wanted to go over what the difference is between ionic bonds and covalent bonds in the shortest amount of time possible. So again, leave a like, comment, subscribe if you have to, and we'll get into more topics. All right, guys. Thank you very much. Peace.